Let's wrap up ionic bonding. So, an ionic bond forms, remember, when electrons are transferred from one atom to another. The movement of electrons is the formation of the ionic bond. So in sodium 281, or perhaps let's look at its Lewis dot structure, sodium with one valence electron. When it transfers an electron to chlorine, for example, 7 valence electrons, the transfer of electrons, or this electron moving over to here, is the formation of the ionic bond. You then end up with an Na plus and a Cl minus. These then stick together, and that's a type of intermolecular force that we'll talk about soon, called an ionic force. Remember, ionic bonds happen between metals and nonmetals, or between metals and polyatomic ions. What are some applications of ionic compounds? Well, let's talk about their properties. They have a definite crystal structure. Think about salt, right? Salt is a repeating pattern. When you take more chemistry, we'll talk all about those structures. They have really high boiling points and really high melting points. They boil, turn to a gas, or melt, turn to a liquid at very high temperatures. You think of salt, it's very brittle, it's very easy to break. As a solid, they don't conduct electricity. But when you dissolve them in water or turn them into a liquid, they do, right? Remember the difference between dissolving in water and turning to a liquid. Liquid means you heat that salt up so hot that you get NaCl liquid. NaCl aqueous means you add that salt to water, right? Both liquid and aqueous will conduct electricity, and we therefore call them an electrolyte. This highlights all the states of matter, and again reinforces the difference between liquid and aqueous. We'll also talk a little bit this year about hydrides and hydrates. A hydride is simply an ionic compound where hydrogen forms a -1 ion. So NaH, for example, would be sodium hydride, Na plus and H minus. Same thing with MgH2, magnesium hydride, Mg2 plus, H minus 1. Hydride refers to H minus. Usually hydrogen forms a positive ion, but in this unique situation, it forms a -1 ion. A hydrate is a little different. This is where you have an ionic compound like copper sulfate, where water is kind of stuck to the structure. We'll use copper sulfate pentahydrate in the lab several times this year. This picture kind of shows us a little bit of where we're going. It shows some Lewis structures for covalent compounds, and it also shows the copper ion and the sulfate ion. We'll talk more about these structures